I am Alberto Palacios and this is The Grip Quintessence. In the previous episode, we dismantled the physics and dynamics governing the unsprung mass of the Pagani Utopia. We saw how the air and lateral forces interact with the tire and the wheel rim to maintain chassis stability at the absolute limit. However, theoretical physics demands real materials capable of enduring the punishment. Welcome to Video 5. Today, we leave vehicular dynamics on the tarmac and step into the metallurgy and aerospace chemistry laboratories. We are going to dissect the ESP-32.1 and the ESP-33.1, the atomic secrets behind forged avenal and the molecular resin that redefines the concept of grip. Video 5, Materials Science and Manufacturing, Aerospace Metallurgy and High Adhesion Chemistry, 1. ESP-32.1, The Secret of Forged Avenal. Concept, why the wheel rim material determines its structural strength. Analysis, we leave shape behind and dive into metallurgy. The Utopia's wheel rim is not made of conventional aluminium, it is forged in Avenal, a 2000 series aluminium-copper alloy. We explain how the crystalline structure, aligned by high-pressure forging, allows the spokes of the wheel rim to be extremely thin and lightweight, yet possessing a yield strength radically superior to that of a common supercar. It withstands loads of 2.2 G without undergoing permanent plastic deformation. Key visual, stress-strain graph comparing Pagani's Avenal against a standard aluminium alloy, showing the exact point of fracture and fatigue. 2. ESP-33.1, HP, High Performance, Chemical Compound. Concept, microrheology in the polymers of the Pirelli Corsa tire. Analysis, we analyze the chemistry of the tire at a molecular level. It is not just rubber, it is a matrix of advanced polymers, silica, and high thermal resistance resins developed specifically for this chassis. We explain how the compound alters its viscoelastic state upon entering its optimum temperature window, between 85 degrees Celsius and 105 degrees Celsius, allowing the rubber to microscopically interlock with the roughness of the tarmac to generate pure grip without degrading prematurely. Key visual, molecular animation of the polymer and silica matrix adapting under pressure and heat to the roughness of the tarmac. In conclusion, the performance of the Utopia is not merely down to its engine power or the setup of its dampers. The true secret lies within the metallurgy of the Avenal and the molecular chemistry of its polymers. It is the ability to maintain structural integrity under extreme loads and to transform the rubber into a viscoelastic element that fuses with the tarmac. When materials engineering is executed at this level, the boundaries of physics expand. However, having the maximum grip on the planet is utterly pointless if we do not understand what happens when we decide to interrupt it. In high-performance physics, braking is not simply a matter of reducing speed, it is a geometric process of deceleration. We are talking about a brutal negative acceleration where the brakes do not destroy speed, but instead seize all the kinetic energy accumulated by the vehicle's mass and instantaneously transform it into thermal energy through extreme molecular friction. When velocity is converted into pure heat at over 1000 degrees Celsius, you require a system capable of devouring that energy in milliseconds without succumbing to thermal fatigue. In the next video, we enter the core of the most violent energy transformation system in the car. Prepare yourselves, because we are going to dissect the especially VVA9, the physics of extreme deceleration and the aerospace engineering behind the Brembo carbon ceramic discs of the Pagani Utopia. Velocity is nothing without the absolute control of energy. See you in video 6.